Well, hi, good morning. Thanks so much for joining me here in my shop. It's April 17th. I just finished 2 German Nordmende radios, and oh my gosh, here's the third one. The third Nordmende. This one's called the Boheme. The last 2 were the Caruso and the Turandot. But this one is the Boheme. Hi-Fi Boheme. Nordmende. At least that's how I pronounce this. I hope I'm close to correct. So I've done nothing with this radio except test the vacuum tubes in it. And I can't even remember the result of that. It was a little while ago. So, Boheme C. So the Caruso I did was the Caruso C. I wonder what the C is for. Is it possible it's Canada? I don't know. Got some other interesting things on it. Scuppa 7874. What is that? Scuppa 7874. Okay, so I've had the back off. That's why this is unplugged and why the power cord is out. I have not operated this radio. Like I said, I'm going to have to read my notes to remember which of any of the tubes were weak in it. So it has a fairly common EL84 output tube, and it looks like it's got the original capacitors in it still. Yeah, there's one here. So it looks like nobody's done anything to it. That's probably the original stabilizing capacitor in the FM detector right there. Probably needs, almost certainly needs a replacement. We should probably plug this in and turn it on and see what it does before I do anything more. I'm not even going to take it out of the cabinet. I think we're going to give it a go right as it is. We'll see what's up. Plug in the FM antenna here. It has a built-in loop antenna just behind this brown thing. And for short wave you'd have to hook up something here. But we won't worry about short wave right now. Here's the power cord for it. Let's jump right in, see what happens. Now I have a way of powering something up like this, which is low risk. If there's a short circuit in it, I don't risk damaging anything. In particular, the power transformer would be the concern. So we don't have to worry about that. Better get a little parts cut going. Okay, so the system I use to control the power is something called a dim bulb system. System's a strong word for what it is. So these 2 light bulbs here are just connected in such a way that when I have these switches thrown appropriately, the power reaching this radio must pass through these light bulbs on the way. The light bulbs act as a restriction. The result is the radio gets reduced voltage, and if there is a bad short circuit in the radio, then these lights will come on and they'll restrict the amount of power flowing into the short circuit. If perhaps there's a short circuit right in the power transformer or something like that. It's very unlikely, but it can and does happen. So we don't want to find that out by plugging it into the wall and then hoping my house breaker will operate if there's a short circuit in here. That's not a good idea. The other thing about the lights is they become a bit of an instrument in the way they get bright, get dull, and get bright again. So if a radio is operating somewhat normally, if it's drawing power in the normal way, what we'll see happen is the lights will come on very bright while the radio is drawing current into the cold heaters. It takes a few seconds for the heaters to heat up in the tubes. Their resistance goes up, the power goes down, the lights go down, and the voltage comes up on the radio at the same time. Voltage on the radio can be read in a number of places in my shop. This is the best place on this guy here. It also shows up on this meter, and it even shows up on this meter. So lots of things to look at. I do have a variable power control here, which I don't do much with, in fact, because I like the lights. I like the lights because they slap you in the face if something's going wrong. The meter, it's not going to slap you in the face. I need some slapping now and then. So that's why I like the dim bulbs so much. Very, very simple thing too. They do what they do. It's just an on-off switch, selector switch. There's nothing to it. So I like the simplicity and all that. Let's just check and make sure the buttons stick. They do. Off. So the first thing we'll do is we'll apply power with the unit off, and we'll see what happens. Nothing should happen. So these lights should not come on. All my meters will go up. This thing will report the line voltage that has been set by this guy. It should be around 117, something like that. Are we ready? Sure. Okay, so I'm going to throw this switch downwards, puts the power through the lights. If I throw it upwards, power goes straight from my outlet straight to the radio, so there's no dim bulb in the way. Here we go. And nothing's happening, which is perfect. The lights didn't come on. This meter went up. This guy tells me it's 119 volts at the device. Now my actual line voltage here in my house is 120 volts. So 119 volts here. So where that last volt is going, I don't know. It's not making it here though. There we go. So by the way, I am plugging into a isolation transformer. Not only this, but there's another isolation transformer behind that. So so there's no ground reference for the 120 volts or 119 that's coming here. And that's for safety's sake. All I got to do is just turn it on and see what happens. So the way I'm going to do that, I'm going to hit the switch. We're going to pick broadcast. We're going to make sure the volume is up just a wee bit. Now, drum roll. I don't have any drums. Here we go. Brighten down. Now we watch. It should come back up a bit. It may not be visible in the camera. And we should start hearing stuff. Oh, I see the magic eye is operating. That's a big indicator of success here. It's dull. Here comes the radio. So in my shop here, there's all kinds of interfering noises. You can see the dim bulbs come up a bit. That's from the extra power now. That's actually the working power, if you like, that's flowing through all the tubes. Now they've all heated up. High voltage has been developed in the set. The fact that this guy is, well, it's hard to see, but we're only running on 90 volts right now. So that's pretty low for a radio like this. That's on the fringe. So it may not behave normally. Let's see what we get out of it with this restricted voltage first. So there's no lights. Where's the pointer? There it is. There's the pointer. So now that noise, not the crackle, but the steady buzz. Not sure I can identify what that is. Yeah, I don't know. It's either coming right from the radio or which would be a little unusual, or it's picking up something that I don't normally hear on radios. You can't tune it in or out. Okay, I'm going to give it full voltage at this point. There's still protection in this device, and there's a fuse right here. I've got loads of protection because I don't want to depend on my house circuit breaker. Okay, we'll go full voltage here. It's got a wee bit lighter. Volume got a little higher. Tune around. No idea why it's doing this. But it doesn't seem to be picking up a thing. Now, it could be the button here. These radios are notorious for having dirty switches in them that misbehave. Let me just make a quick check of something here. Just bear with me while I check something on my computer. Hear the crackling? Right. Focus a little better there. So there's no lightning storm outside. It's blue sky, the sun is shining. So now you can't smell anything, but I sure can. It could be this just hasn't been on for a long time and I'm heating up dust on the surface of tubes and stuff. But it doesn't smell the greatest. We're at 115 volts. Why not 120? I don't know. This has been bothering me a little bit here. Somewhere I'm losing a bit of voltage along the way. But don't worry about that. So chances are shortwave sounds pretty much the same. Yeah. And there's no antenna, so no use tuning it. This is another shortwave band. Probably sounds the same. That tells us a little bit about where this kind of noise could be coming from. This could be everything from a bad capacitor, bad resistor, or bad tube, or even just tubes not in the socket, not making clean connection in the socket. Although I doubt that's the problem. Okay, we'll try FM. So this went right off. That's a very bad sign. Sound disappeared. Let's get it off that. Okay, so that was a very bad sign. I want to push FM and see this disappear. That suggests there's a short circuit in the radio somewhere. That's just a suggestion. Who knows? We don't know anything yet. We know this much. Not working very well. Never saw this react to signal strength. Never heard any stations. Hearing a crackle. Now where'd that buzzy sound go? Because I don't hear it now. Oh, son of a gun. That's the dirty switch thing happening. Now yeah, you know, I'm going to shut it off because something is cooking. Exactly what it is. It could be nothing more than this tube getting really hot. But it could be lots of things more besides that. It kind of has the hot dust and smell. It doesn't really have the burning component smell to it. Okay, well, we got an idea what it does. It doesn't do much. Okay, we'll shut off the power completely. The next step is going to be to get this out of the cabinet on the bench for a better inspection. You might think, oh my God, turning on an old radio like that, are you crazy? No, I'm not crazy. I guarantee it. I'm not crazy. I like doing that because I like to know the state of affairs before I start working on things. If I feel the situation is safe enough, I will power it up. If I don't, I'll do what I think I have to do to make it safe enough to power up. I try to get it powered up as early in this process as possible. And it's all because of the wonderful dim bulbs over there that I can do this. Although there's other ways to avoid a disaster when you're starting it up. I did test the tubes in here, and for crying out loud, I don't remember the results, so I have to do a little bit of research, but clearly the output tube is working because we could hear sounds. From there, any one of these might be bad. Wish I could remember. And why did the whole thing seem to die when I pushed the FM on? That's a very good question, especially the Magic Eye. The Magic Eye should still be operating in FM. So something is out of sorts with it. Okay, I'll get it out of the cabinet and we'll take a better look at what's going on in it. Now let me show you something about most of these radios. Underneath, well, okay, I won't show you. I was going to show you the panel that can be taken off here. No panel, no panel. There is something else that you need to look for. So those panels, whether it's there or not, doesn't quite make makes sense what I was going to say. So there's probably, well, you can see it. There's a sheet under here. You can just see the edge of it poking out. An aluminum sheet or a metal sheet of some sort. And then that sheet needs to be grounded to the chassis. So there's often a wire coming from down under here onto the chassis somewhere. So you need to look for this, because if you try pulling out the chassis without finding it, you're going to find it the hard way. So I can see where it is already. It's right here. So that connection has to be separated before you try pulling the chassis out. I don't know that there's always such a thing, but very often there is such a thing. So now it seems like that's an odd size. Odd size. No, that's not going to work. Now we'll just do it with some pliers here. Not the best pliers. Let's try these. There we go. Okay, well, since the video's rolling, I might as well extract the... Hey, what's happened to the focus? What's going on with my camera these days? Yeah, I don't like autofocus. I hope it hasn't been blurry like that the whole time. Oh my gosh. Well, you know what I'm going to do? I'm going to do this, I'm going to do this, and do that. There we go. I don't know what it is about autofocus getting stuck. Okay, now I'll try to pull this out. So I'm feeling for other things that might be in there that I don't know about. You notice there's big speaker here, and then there's two tweeters, two electrostatic, I'm pretty sure electrostatic tweeters there. Just noticing where the dial string is floating right through the middle here. So this is the speaker plug. I'm going to leave them plugged in for the moment. What else is holding this from coming out? I did take all the screws out. 1, 2, 3, 4. Seems to be attached up here. Caught on the rubber mount. If I just kind of lift it up, it'll free up. You want to be very careful reaching your hand into one of these radios, because you can accidentally grab the dial string, and once you break that, you've got lots of fun coming. There it goes. Okay, I don't know what it was stuck on. It was stuck on something. Okay, I'm watching the wires as I pull this out. There's a light bulb here. The bulb is missing. Bulb is entirely missing. It's a little odd. Oh! Okay, I can kind of see something in there. Let's pull this out. Pull this out. I forgot about this. Go slow. Take your time. Don't get into trouble. Okay, and we're going to pull this light bulb off its fixture. Light bulb socket. It's a bracket here. There we go. Now, these are often made so you can get the chassis out of the cabinet and leave the speakers connected. And that's the case here. Okay, a little bit too much for my turntable. There it is. Okay, next step is to do a little inspection. So what they've done here with the light is powered from the same source as all the heaters in the tubes. So they've come over to this tube, this is the Magic Eye tube, and they've simply tapped off the heater terminals to bring 6 volts up for the light. Well, the light is sort of there. I the glass part is gone. The last radios I worked on, these bulbs did not come out easy. There we go. Might as well pull it out now that I'm here. So what's happened is someone's reached in and grabbed the glass and broken the glass off, which might have been kind of exciting for them. That's the glue. That powder that's coming out is the glue. That cement, I guess, might be a better word, that holds the glass bulb in place. So I'm going to shrink this down. There we go. There we go. There it goes. So I have some LED replacement bulbs that will work in this. That should do a good job. Been very happy with put them in the last two radios, and they worked out quite well. Okay, so we can forget about that for now, though. Let's just take a look at what we've got here in this radio. My camera can't decide what to focus on. So what I'm noticing is the number of old style, old capacitors. These brown ones, like what I'm pointing at here, I think are very unreliable. You can see 1, 2, 3, 4, 5, and then well, I can see 5 offhand. There's probably a couple more. Probably come into view. 5. And I want to look underneath. So I think at this point I'm going to remove the speaker cord. I don't want to be twisting it any more than necessary. So what's this orange wire doing here? Wire separate from the plug. It could be they used all the terminals here. No, there's an open terminal. Why this wire is running externally? This orange one up here, goes straight to one of these speakers, which I'm pretty sure are electrostatic speakers. So electrostatic speakers that don't operate at all like a regular speaker. Regular speakers use current and magnetism to cause the cone to move. These ones use high voltage, and they use the electric field to move the diaphragm back and forth. So these have high voltage on them. You can't go put a regular. You can't take these out and put a regular speaker and hook it up to the orange wire, or bad things are going to ensue. So I'm just going to take a guess that for some reason they didn't want to include this wire inside the bundle. They didn't want to include it in this connector because there's a couple hundred volts on it, I guess. I don't know. Don't know why they did that. It's not helping me much, though. I could separate it here from the tape. And there's more wires going up to the speaker. Wait, what's going on? Oh, this isn't the speaker. This is going, yeah, I got it, okay. Completely wrong in what I was saying. So up at the top, kind of just below my thumb here, is the push buttons for tone control. For some reason, German engineers just love tone controls. And not only would there be tone dials, probably on here somewhere. This is rock solid. So the tuning, just studying the knobs for a minute. So very common in these radios. They have 2 pointers. There's a pointer down here, and then a pointer over here. One is for AM and shortwave, and the other one's for FM. So I only have 1 tuning knob. So how do they get 1 tuning knob and 2 different pointers? They have a transmission or gear system down here. So if you select, let's say this is AM broadcast in this case, it sits like that. And if I push the FM button, it moves the gears, and that transfers the drive that I'm turning here from turning this tuning system, that's the AM one, to moving this one. Occasionally there's trouble with this system. And really, you do not want to break one of the strings in the radio like this. Big headache ensues after that. So there is this string going right through the middle of space here, and kind of an unusual thing. Usually the strings are all down low. I got one here that I can easily catch while I'm working on it. Other thing of interest is this guy right here. So this is a fuse, I believe, to protect the speaker, the output transformer, or the radio generally. And the way this works is this piece coming over, this is an insulated piece here. This part coming over the top is actually spring loaded. If it weren't for the fact that it's soldered down here, this thing would pop open. So the idea is this thing can heat up. Some of the wire on it is passing through the inside, so this thing can warm up. I guess if there's a serious enough problem, it's going to warm up enough to actually melt off the solder, and this thing will pop open. And if you found a radio like that, that's a very bad sign. That's what I would say. Very bad sign. Could mean there's a short inside the output transformer, which is somewhat suicidal for the death knell. I guess that's what you would say. Okay, so all these wires that are still connected are the speaker wires. Now there's a chance having this unplugged will stop the radio from operating. I don't think so though. I'm going to cut this paper and free up. You're free, buddy. You're free to go. Free to roam. Okay, other observations. This appears to be tilted a bit, but I guess that's just the way it is. Just looking around in there. Anything a little bit unusual. So there's this down here. Looks just a little unusual to me. So it's on porcelain lifters that are supposed to kind of raise the resistor up off the board because it's going to get warm. Well, that looks like it's pushed down. Looks like somebody's pushed it down. In fact, even the dust is off one end, as if somebody stuck their finger in there and pushed it down. Is that really what happened? Who knows? Who knows the truth about these kinds of things? So there's other capacitors in here, which, one like this one, I would say are probably quite reliable. One here too. I wouldn't go in initially and try to clear those out. I'm looking for any parts that appear to be overheated. I don't really see anything like that, but wasn't I smelling something? Plus there's no dust on these tubes, so not likely I was smelling tube dust being cooked up. This capacitor here, the end seal is cracked open on it a bit. That's not surprising. These often look just terrible. I have a bag full of them here somewhere. I think it's out with another radio now that I could show you, but sometimes they just look horrendous. Doesn't necessarily mean they're bad, but if you want to bet, you would bet they are. Okay, so there's nothing really leaping out here at me. It doesn't look like it suffered any kind of horrifying damage of any sort. Like when the fellow was fooling around with the light bulb, he probably didn't pull it off. He pull this part off. He's probably reaching inside, and look at the string is right here. He could have broke it, but he didn't. Very good. Now we want to tip this thing. I think we can lay it on its back. Take a peek underneath. Let's see what we've got there. Okay, that's good. So, a few components, not too many. Here's the on-off switch, which is a kind of a regular toggle switch. And this one's got a mechanical linkage to the button here. Oh, let me just pull the plug out. There's no power, but I don't like I don't like seeing it plugged in. I like seeing it unplugged when I'm doing this kind of stuff. So these two capacitors here are almost certainly conveying the audio. And there's another one right here. Sometimes these are special shielded capacitors. In fact, this one appears to be the case with this one. It's got one lead here, one lead in the center there, and another one coming out, a third lead from a capacitor, and it looks like it's going to a terminal to which a black wire is connected. Black can often mean ground, and it's going to this terminal, and there's a big, it's definitely a ground. So this is a shielded capacitor. So I want to jump in and change this right away because I don't have shielded capacitors. And this is a mono. This is a mono. I don't think there's any stereo capability whatsoever. There'd be two output tubes or a 2-in-1 output tube. There isn't. It's just a regular output tube. So no stereo. So just one of these capacitors. The other two are kind of regular capacitors. So as I say, if you assumably they're shielding this because there's a very weak signal at this point, and then it's going to be amplified quite a bit. And if you let any hum get in at that point in this circuit, you're going to end up hearing it. Hum, buzz, interference, whatever it might be. So we use a shielded capacitor here. Just how bad it would be without it, I'm not sure. I have replaced them in the past with unshielded capacitors, and it hasn't been a problem. If you notice right in here, all these wires are squashed terribly because they're not supposed to be where they are. So this radio's been sitting on top of all these wires here. It's just squished them all together. So we're going to want to fix that. A little bit surprising would be like that. And look for any that are actually, the insulation is broken. I'm just going to push them out of the way. Wow, that's still insulated, but look at this one, brown one. Wow. Really too bad. How did that happen? It's been like that since the day they built the radio, I think. That's exactly the kind of thing that could be just on the edge of failure, and then I'm fooling around in here, and over the edge it goes. Okay, that's a little better. This is the power transformer right here too. So this will get warm to some degree, and maybe in a dilapidated radio it may get quite warm, and that's not going to help these wires that are under pressure. And you know, wires that are close to the transformer may be carrying a lot of power, or the potential for a lot of power. So a short circuit happening in here, it could be a bad thing. This is the fuse holder here. Now we take a look at the fuse. Well, I can't get at it right at the moment, but try to remember to do that. These are inputs, phono and tape, almost certainly the two inputs. This is probably a speaker output, I'm kind of guessing. And what it is, the back of the radio will tell us the truth. Hey, and what else is on the back of this radio? Something well worth looking at. It's all in English. The Boheme C. For AC 110 volts, 50-60 only, cycles only, power consumption 45 watts. Pull out electric plug before removing back cover. Keep dry. Keep dry. There, use fuse 0.6 amps, slow blow, exclamation mark. Because as you saw with the dim bulbs, when you first turn this on, it draws an extra rush of current. You don't want that to pop the fuse. So you use a fuse that can tolerate a short period of high power, 0.6 amps. FM outdoor dipole on all wave bands. FM outdoor dipole, position number 1. Oh, so this is moving. We can't see it. It's on the back of the radio here, but there's a link here that can be moved. Position number 2. FM outdoor dipole separated from aerial. But we're using the dipole. We're going to be using the dipole that's built into the radio. These are usually, you can see a little bit of it here, the aluminum. These are engineered antennas. They should work quite well. But I guess if you want to put an outdoor antenna, you'd have to fiddle around with this a little bit. Please indicate those numbers in any of your inquiries. And there's a little plastic window here. You can look at the back apron of the radio and read some numbers. Tape recorder, recording and playback. So this is not for phono. This is just for tape in and tape out. Phono. So it's got a position here where if, I guess some models had a phono input also. It's just a big hole in this one. No phono. You might be wondering, gee, can you hook up Bluetooth to the tape input? Probably can. Probably can. Oh yeah, that's right, that's these. Additional speaker jack, that's that. If connected to 2 and 3, only outside speakers operating. Okay, not exactly sure why that would be. 4.5 ohms. That's what they're suggesting the speaker should be. Not your usual 8 ohms. With 4.5, you could take 2 8-ohm speakers, put them in parallel, and there you are. Generally speaking, though, these radios sound great with their own speakers. Oh, look at that. We got a diagram in here. Shows the different tubes. Output tube, EL84. The indicator tube, EM84. EF89, EABC80, ECH81, ECC85. Just about all these Nordmende radios have the same tube lineup. That's my experience. Schaltplan. That's my attempt at speaking German. I won't attempt it anymore. So this is some kind of tag. Most of it is gone now. That was put on the radio by somebody, maybe when it was new. I don't know. We don't know what it says. We're set. So here's a Nordmende, and then here is a number, a chassis number, in case that might help scare down or scare up the schematic. Spring here, pulling some bad dust deep inside. So again, I'm just looking for things that are discolored. We're going to get the other camera out and take a close look around the output tube. Some of the soldering on the output tube. Let me do that. So I'm going to have to stop for a minute and fix the focus because we want to get up pretty close with this camera. So, well, maybe I won't stop. I'll just quickly take care of this here as quick as I can. Okay, we'll adjust the focus way in. The reason I want to look at the output tube is the output tubes are hot, and these are really hot. And the heat can degrade the solder. If you look at the board, sorry, I've got it out of focus now. The board is discolored all around here from the heat of this tube. All tubes get hot, but the output tubes get really hot. And I would say there's some evidence of the solder failing in here. Now, the radio was working. At least it was making some sound. So all these connections we're looking at, the circle of connections, are the pins from the socket. So I would say a little dab of solder wouldn't hurt any of those. Might be worth doing. While I've got this out, this camera out, we'll look at a few other things a little more closely. Appear to be in fairly good shape, but they're probably not reliable. There's another sticker here. I don't know why they would have a sticker there. Generally at the board, we're looking at the connections into the IF transformers. Those four brown prongs sticking out are terminal board. I can't, because of the camera angle, you can't see underneath, but if you could, you would see that that solder runs up onto the onto those things. So there's another possible spot for a solder failure to occur, but I can't really see from this angle here. Can't tip the radio back. They're running some risk. Well, it looks like they've been, well, I don't know what to say. Somebody went at them with a soldering iron. It's possible in the factory. Part of the process is at the end to inspect and then touch up any soldering that looks a little crummy. I don't know, just making all that up. Looks pretty good otherwise. I don't think there's too much to hunt down here. Here's these wires that got crushed. Looking for any exposed conductor. No, I don't think so. I don't think that happened. See that brown one there. Really pinched down, but it's okay. No metal showing. Oh, it's not so hot, is it? Right on the edge like that. Okay, so this thing we're looking at now is the rectifier. This is a type of rectifier which some people would believe is unreliable. My experience with these is they're perfectly fine. They have a long life. These are better built rectifiers. These are not silicon rectifiers that are based on selenium. Selenium involved with them, and cheaper selenium rectifiers commonly found in North American radios do fail, and apparently it's not fun when they fail. Apparently they produce a lot of terrifying smoke and smell. So the way we can check this is at some point I can check it for heat, if it's heating up at all, but there's no evidence that it's in any kind of a bad state, so I don't normally change these willy-nilly. I did in the past, but I don't anymore. I don't think there's any reason to. Okay, again, while I've got this close-up camera going, let me just flip around to the top again, the top and the back. See what's to be seen. Whoops. Okay, let's go back to the close-up camera. It really isn't a close-up camera, by the way. It's just a camera that manages to focus really closely. So we're looking down inside the FM tuner. The last two radios I did, the alignment of the FM tuner was terrible on both of them. And performing a realignment on it basically saved those two radios. It just brought them back from dead FM. So really quite surprising. So there's some kind of component drift going on inside this box. I don't like to work inside these. I think you're running a risk. I don't really want to run. So hopefully this one, well, there's something more wrong with it because nothing was receiving. No AM, no FM. So these are all the alignment adjustments for broadcast band and shortwave. Probably end up fiddling around with these once at some point to raise the performance of the radio up so it's like new. Okay, so now we're going to take a close look at. I got to change the focus because I can't get my camera quite far enough down there. So just do that. So again, I'm looking for obvious signs of degradation. That capacitor there is tucked very close to a tube. The tubes get hot, the capacitor gets cooked. Seems fine though, although there's a lot of dust in here. The other radio I did, that capacitor, and the one right there, another one that's tucked up against the tube, they both cracked right open. I'm talking about this one here. Otherwise, those are very reliable capacitors. Now, I don't know what to think of it, but you see this resistor has a little hole in it. I see that a fair bit in these resistors. I don't know what it means. There's another one I think has a hole in the end of it. It's not very reassuring. There is, of course, just inside the resistor, there's a connection between the lead wire coming out of it and the element inside the resistor that's doing the resisting. And that connection can fail. I mean, that's commonly how resistors go south, especially if they're open. Often the connection has failed inside. Like a failing connection would get hot and burn a hole. You can see the hole up in this one. I don't know what to make of it. I see it all the time in these. So this capacitor, let me get a pointer here. Where is a pointer? I need one. This will kind of do. This capacitor here is an unreliable type. It should be changed. Nothing appears terribly overheated. Now, let me come around and come down this way. So this capacitor looks weird to me. It looks dark. It's sitting right up against the output tube. This is a real hot cooker. So I think this capacitor's been cooked. It doesn't mean it's bad. It means it's the outer covering is discolored. It's gone dark. In fact, if we come at it from this end, I think you can even see it has shrunk back here. So this guy's definitely a target for replacement, just by looking at it. This yellow thing is a coil. These radios are all so similar. And there is the key FM capacitor, this one here. So this guy's got a big job to do. It's electrolytic capacitor. Big job in the sense that this has a big influence on the quality of the sound on the FM side. This guy always needs to be replaced because you need to know if you've got a good capacitor that's usually 2 or 3 microfarad, something like that. That says 5/70, but I don't know what that means exactly. Okay, what else we got here that's worth looking at? So I'm going to have to test all the tubes in the radio again. I think well, I've got some notes somewhere, but I think I'm probably going to want to test them all again. Now what's going on with that? That's the resistor that I mentioned looked like it had been pushed down. Is it cracked right open? Let me bring in my dental tool here. Yep, there's something going on there. It's either something like a string of, I don't know, black tar has, like a spider web has fallen on it, or that's a crack. So it's a fairly large resistor, which means it's a fairly high wattage, relatively high wattage, or it's expected to get warm. You can see these insulators, the one here and the one over on this side. So the purpose of these is to stand this up off the board. But you can see clearly it's been pushed down onto the board. These things have tipped. And what is this? It's junk. So now is that junk coming out of this? I don't think so. Is there black junk in something like that? What it does say is something's getting hot around here. Maybe this is what I was smelling. Maybe this guy. So that's a definite target for replacement just on visual observation. Now what's this guy here? I don't know if I can get the camera in on it. I need some more light. More light. Well, I think that's a capacitor there. Is it this one? No. What happened? I looked away for a moment. There we are. So if you see an unusual looking capacitor, there's always a chance it's a special capacitor designed to change with temperature. It's a temperature compensating capacitor. How critical it would be, I don't know. Is that what this is? I don't know. Is it even a capacitor? I don't really know for sure, just looking at it. It's a strange looking thing though. Looks different, different than the rest. Wouldn't want to jump in and change that without being thoroughly conscious. I spend most of my day, semi-conscious, so. Now what's going on this resistor's got some kind of schmozzle on it. What's that all about? Doesn't feel right. So this could be a failure of this resistor. It could have, again, the terminal connection from here, just inside the resistor here, will cause heat to right in this area, and maybe it's actually burned through. I don't know, or something dripped on it. Hard to say. What would drip on it? There's nothing above it. Okay, I think that's the end of the tour through it. Nothing too egregious. I'll just stop and take a look at the output transformer. No sign of overheating in the output transformer. And there's that fuse I was talking about. Fusible link might be the name for that guy. See, the body is made of probably porcelain because it's designed to run with some heat in it all the time. It's just under adverse conditions, the heat gets so high it'll melt this. And boing, it'll pop open. So if you're looking at one of these radios at a yard sale and you can manage to see all the way into this, and you see it's popped open, you might not want to spend your $10 on that radio. Good. Yeah, I think that's it. I think that's the end of that. Very good. So, okay, so we've had to listen to it. It largely works. Something coming out of the speaker. Doesn't seem to tune anything. Push the FM button. Looks like the high voltage was taken away because this tube went blank. It disappeared. The high voltage taken away. Why? Because a short was introduced at that point. Well, that's it. That's it for today. So thanks a lot for watching. I got a day now to think hard about this and decide how I'm going to approach the repair of this radio and getting it going again. Thanks a lot for watching.